Hello, my name is Joshua Long, and I will be talking to you about electricity, magnetism, and future travel. As time goes on, more people populate the Earth each day. This means that our world gets smaller and our fossil fuels dry up just a little faster. Billions of people across the world now have cars and transportation in general as a necessity. International business and trade growth have called for the need of faster and efficient transportation, but it's only a matter of time before our fossil fuels dry up completely. Not to mention, people are already pushing strongly against fossil fuels due to global warming. Our technology has not advanced far enough to eliminate fossil fuels being used for transportation, but we are pushing headstrong into it. Currently, electric cars have been created by several manufacturers along with hybrid cars that are run on both electric power and fossil fuels. The pure electric cars are not as popular as the hybrids because of the lack of charge ports on roadways where people can charge their car. In rural areas, electric cars and charge ports are almost non-existent, but in cities they are much more common. The United States is behind other countries like China and Europe when it comes to transportation of the future. Electricity and magnetism are the future to our transportation, not just for vehicles on Earth, but for vehicles to take us off of Earth. Some examples that are being created and or already being used are electromagnetic suspension, linear motors, solar roads, plasma propulsion, and air propulsion. First of all, electromagnetic suspension is already being used by maglev trains in Japan, China, and South Korea. According to Heidi Riddell, 2017, the three components to this system are a large electrical power source, metal coils lining a guideway or track, a large guidance magnets attached to the underside of the train, and this type of train does not use fossil fuels, but instead uses propulsion from magnetic fields created by the coils. Maglev basically stands for magnetic levitation because the train is actually levitating due to the magnetic fields and can travel at speeds over 300 miles per hour. The United States has not implemented a maglev train yet, although the Japanese Prime Minister had a talk with President Trump about implementing one between Washington, D.C. and New York earlier this year. The travel would only take 1 hour, but there has been no further word of the matter. However, the Chattanooga Times Free Press had an article discussing a federal study that has taken place over the last decade to implement a maglev train between Chattanooga and Atlanta. According to Mike Pear, 2017, the federal environmental study sets a preferred train route that's aligned with Interstate 75 between the cities. It calls for building 8 rail stations along the 120 miles of I-75, starting at the Atlanta airport and ending in Lovell Field in downtown Chattanooga. Travel time is 88 minutes from the first to last station. Secondly, linear motors are being discussed for future transportation. This involves putting electric motors under the roadways, which propels electric vehicles along the highway. According to Keith Barry, Ford's Speedway Transport System concept uses a network of linear electric motors to propel electric vehicles along the highway. He sees us driving around in futuristic dual-mode electric vehicles with small motors for city driving. When we're ready to leave town, a contact-free linear motor would propel the car over long distances with a drifting magnetic field. Ford says linear motors would work under our existing roadways, complementing, not replacing, existing automotive technology. If this was ever to be implemented for everyday vehicles, the Autobahn would be the first to see it. Linear motors create a linear force along a flat stator. Its moving magnetic field will repel the opposite magnetic field of a conductor and move the vehicle. The magnetic field also charges the vehicle as it travels. Maglevs also use linear motors, and these motors convert electrical energy to mechanical energy while using magnets to propel the vehicle. The magnetic flux stays concentrated at the poles of the magnet, and its strength is increased by adding coils and increasing the current. Thirdly, solar roads could be used for future transportation. Instead of asphalt or concrete, solar cells could be placed beneath a layer of sturdy glass. According to Glenn Heimstra, 2013, operating at 15% efficiency, the U.S. road system would provide more than 4 times our current electricity needs, or about as much electricity as the whole world uses. It's a lot of potential power. The biggest holdup is that it is hard to manufacture a glass that can withstand a tractor trailer's weight and not break, but still be clear enough to allow sunlight to the solar panels and not emit too much glare. Solar roads can also allow safer travel because LED lights can be implemented into it to display the lines on the road, such as the double yellow lines and white lines. Also, it could be used to show which lane is a turning lane or an exit lane or even a bike lane. This could cut spending on paint that is currently used for the lines and signs on the road. It would also prevent drivers from trying to read old, faded paint on the roads because it will all be LED lights and allow clear vision of the signs. Messages could also be displayed on the panels to indicate if there is a reported traffic incident up ahead, meaning more time for drivers to be aware and slow down. Fourthly, plasma propulsion could become our way of transportation into space to other planets. Franklin Chang Diaz, founder of Ad Astra Rocket Company, has been studying and building a rocket engine that uses plasma since 1973. According to Sam Ho Verhoeven, his idea was this: rocket fuel is a heavy and inefficient propellant, so instead he imagined building a spaceship engine that uses nuclear reactors to heat plasma to 2 million degrees. Magnetic fields would eject the hot gas out of the back of the engine. His calculations showed that a spaceship using such an engine could reach 123,000 miles per hour, meaning New York to Los Angeles in about a minute. This could change the world as we know it if it is completed and works. We could travel to Mars and back in less than 300 days, and it would also mean that we can travel farther than Mars to learn about other planets. If technology advances and this new rocket engine is created, then we may be even on track to see flying cars in the upcoming future. Not only that, but this could be what we need to enable ourselves to find ways to live and survive on other planets. Science fiction movies could become our next reality. Finally, air propulsion could be the next best way to travel. This will be implemented by using a train that could get you from London to Edinburgh or Los Angeles to San Francisco in under 30 minutes. Elon Musk, the founder, has named the new train system Hyperloop. According to Max Langridge and Elise Betters, Hyperloop is essentially a train system that Musk calls a cross between a Concorde, a railgun, and an air hockey table. It's based on the Very High Speed Transit (VHST) system proposed in 1972, which combines a magnetic levitation train and a low-pressure transit tube. It evolves some of the original ideas of VHST, but it still uses tunnels and pods or capsules to move from place to place. Musk compared the train system to vacuum tubing like you see at banks and in buildings to send mail or papers. The new train system could travel at speeds over 700 miles per hour, but some of the quirks of it involved acceleration and deceleration sensation that passengers would go through. Hyperloop could use air bearings for the passenger pods that float on air, similar to maglev because it is frictionless. Hyperloop could also use passive magnetic levitation, meaning the magnets on the train are on the train and work with aluminum trackers instead of the traditional maglev that uses a powered track, which is more expensive. The tubes the train would travel in would have a low pressure to cut down on the wind resistance. Musk proposed that solar panels can be placed on top of the tunnels to power the system and allow the train to run underground. In conclusion, our fossil fuels are steadily being used up, and the population of Earth keeps on rising. We need other alternatives to our transportation, such as using electricity and magnetism. Several ways that we can accomplish this would be to use electromagnetic suspension, linear motors, solar roads, plasma propulsion, and air propulsion. These different ways of traveling are cleaner for the environment and are significantly faster than how we travel today. With new technology, we will be able to spend more time working or spending time with our loved ones rather than sitting in traffic, whether it be trains, cars, or planes. This could also mean traveling to other planets and inhabiting them with the technology behind the plasma propulsion rocket. Here's listed the sources that I used for my presentation. Thank you and have a wonderful day.